Okay, so the next lesson is going to get into some different properties that we're going to use when we are simplifying logarithms, and also some properties that are going to let us evaluate some logarithms if they are numerical values that don't come out nice and pretty. So there are three properties that we're going to talk about. The first of which is called product property. So what it says is if you've got two terms being multiplied on the interior of a logarithm, you can actually split those two terms apart into separate log terms by using addition. So what would that look like? If I had something like log base 5 of 2x, I can split this into two separate terms by writing this as log base 5 of 2 plus log base 5 of x. So because those two terms are multiplied on the inside of the logarithm, they can be split using addition. Now the reverse also works. If I start off with something like log of y plus log of 3, I can put these two together back into a single log by just taking the y and the 3 and multiplying them. So splitting them apart is called expanding, and then putting them back together is called condensing. So we're actually going to be doing both of these. We're going to be taking terms that are one log term, and we're going to split it apart into as many separate terms as we can. And we're also going to take terms that are already split up, and we're going to be condensing them as much as we can. The next property we're going to talk about is called the quotient property. What it says is if we have two terms that are divided inside of a log, they can be split apart into separate terms by using subtraction. So that would look like something like log of x over 2. I can split that into two separate log terms of log x minus log 2. The last one is called power property. That one lets you take any exponents that you have inside of the log, and you can bring that number down and it becomes the coefficient in front of the log. So notice where the n is now. So this would be something like log base 3 of x squared. So I wouldn't leave it like that. I would take this 2 and it would go down and it would become a coefficient. So this would be written as 2 log base 3 of x. Using those three properties, we're going to take these four problems and we're going to evaluate them. Now, back before scientific calculators and graphing calculators were a thing, in order to figure out what a value like this was, there was logarithm tables. So in the back of every math textbook, there would be tables and tables and tables of values. And so what you would see is something like base 6. So you'd see log base 6 of 1, and it'd have a column what that equaled. And then there'd be log base 6 of 2, there'd be a decimal. Log base 6 of 3, there'd be a decimal. Log base 6 of 4, there'd be a decimal. Log base 6 of 5, there'd be a decimal. So what you'd have to do with a number like this in number 1 is you would have to split this using log properties, and then you would have to search through the tables to find the correct values to use. So rather than making you search through the tables, I found the two values that we're going to use and break all of these into. So for example, since the 5 and the 8 here are divided, what we're going to do is break this into log base 6 of the numerator, which is 5, minus log base 6 of the denominator, which is 8. So why do we do that? Well, I have a number for log base 6 of 5. It's 0.898. So I'm going to take that decimal and I'm going to plug it in here instead. I have a decimal for log base 6 of 8. It's 1.161. So I'm going to take that and I'm going to put it in down here. And all I have to do now is subtract those two decimals, and it will give me the evaluation, or an approximate evaluation, of what is log base 6 of 5/8. So I get a negative number, so I get negative 0.263. Okay, so I want you to think about what this answer actually means. This is the power of 6 that's going to give you approximately 5/8. Now, why am I saying approximately? This is a rounded decimal. Notice these squiggly equal signs. Most logarithms don't come out to be nice, neat decimal values. They're never ending, never repeating decimals. So they're irrational numbers. So this value here is an approximate value. So if I went to my calculator and I raised 6 to this power, you would get approximately 5/8 because that is a rounded power. So just keep that in mind. Okay, so moving on, if we want to look at a number like 40, what you're looking for is there a way to break 40 apart multiplication or division-wise so that I can use 5 and 8? Well, obviously, you're going to take 40 and you're going to break it into 8 times 5. So why do I want to split like this? Because now I can take this and break it into 2 separate log terms using the property. So I'm going to take log base 6 of 8, and we're going to add to that log base 6 of 5. Now here's the biggest mistake that happens with students. They see that the 8 and the 5 are multiplied, and so when they break the logs apart, they keep it as multiplication. So please keep in mind that when you break the multiplication apart, you're actually breaking it into addition. So you're going to take the 2 decimal values you have. Log base 6 of 8 is 1.161, and this time you're going to add them together. Log base 6 of 5, 0.898. So once I have gotten those 2 approximate decimal values, all I'm going to do is add them together in my calculator. And I get 2.059. Okay, so again, so that we don't lose the idea of what we're finding. This is the power of 6 that's going to give you 40. So let's just test that out. If I take 6 and I raise it to the 2.059 power, you should get 40. Now we're going to get approximately 40 here because remember, this is a rounded decimal. Notice I get 40.01. So it gets me pretty darn close. Now, if I had a longer, if I had more decimal places here and it was more exact, this number would be increasingly close to 40. So just keep in mind, this is the power of 6, but it's an approximate power of 6. All right, let's go to the next one. So if I want to figure out 64, there's actually 2 ways you can do this. You could write this as log base 6 of 8 times 8, which would be fine. You could also write this as log base 6 of 8 squared. Now notice 8 times 8 and 8 squared mean the same thing. So let's talk about what happens if I do 8 times 8. I would break this into log base 6 of 8 plus log base 6 of 8. And notice how many of them you have. You have 2 of them. So since I have 2 of them, I'm going to write it as 2 log base 6 of 8. Now I want you to look at what you had when you had this. According to power property, that second exponent would come down in the front and become a coefficient. Well, if I do that, notice that's what I still get. So either way you break it apart, you end up in the same place. So all I'm going to do is take the value for log base 6 of 8, and I'm going to plug it in here. So I'm going to do 2 times 1.161, and that is going to give me a decimal value. So using the calculator, I get 2.322. That is the power of 6 that's going to give you 64. So if I went to my calculator and I did 6 to that power, we get 64.1. Now again, this isn't exact because this decimal here is a rounded decimal. If I had more decimal places and this was more exact, then this is going to be a lot closer to 64 than what that decimal gives you. Now looking at 125, again, using the values that we have, 125 is the same thing as 5 cubed. So I'm going to write this as log base 6 of 5 cubed. And then I'm going to take that 3 power according to power property, and we're going to put it down in the front. So 3 log base 6 of 5. And we're going to take the value that I have for log base 6 of 5, and we're going to throw it in here. So 3 times 0.898. And again, using the calculator. Oops, that's 898, not 893. We get a value of 2.694. And again, keeping in mind, this is the power of 6. That's going to give you approximately 125. Okay, so there are your numerical examples. Now we're going to get into taking log expressions, so things that have x's and y's and such, and we're going to expand these as far as we can. So notice, they start with a single logarithm written, and when we're done, we're going to write a separate logarithm for every single base you have in the problem. So what you kind of want to keep track of in the beginning is how many bases do I have, so you know how many log terms you're going to end up with. So looking here, I've got a base of 5, I've got a base of x, and I've got a base of y. So when I'm done, every single one of those should have their own logarithm. So how am I going to split this, and what order should I do them in? The first thing you always do, if you have a fraction, always split the fraction apart. Now, according to our quotient property, anytime you have a fraction, all you're going to do is split the inside fraction apart using subtraction. So we're going to write this as log base 6 of the numerator, 5x cubed, and we're going to subtract log base 6 of the denominator, which is y. Now here's the part that you have to be careful on, because this is what students like to do a lot. They see this exponent and they think, oh, power property. That means all I'm going to do is take this 3 and put it in the front. Now here's the problem with that. This 3 is not affecting the 5. So if I put it down in the front, now you're saying that it is affecting the 5. So what you have to do is split these apart first before you can bring the 3 down. So the 5 and the x cubed actually get their own logs first. So we're going to do log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. If that 5x had been in parentheses and the 3 was affecting both, then you could have put it down first. But since that 3 is only on the x, you have to split the terms apart first. Now the last thing that we're going to do, we're going to take that power of 3 and we're going to put it down in front. But notice it's only going to go down in front of the x log term. So log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. And there is your expression fully expanded. We're going to skip the one over here on the right and just come down to here on the one on the left. And so again, first thing you want to keep in mind is how many how many bases do I have? So I've got 1, 2, 3. So if I've got 3 separate bases, that means I'm going to have 3 separate logarithms when I'm done with the problem. So let's split all of these. Now notice they're all multiplied. So every single one of them is going to get its own logarithm, and we're going to separate every single one of them using addition this time because every single one of them is multiplied. Now notice, when I rewrite the logs, I wrote in the base number every single time. You can't get lazy and start leaving off the base numbers, because if you don't put the base number in there, what you're telling me is it's log base 10, which is not what you want it to be. It's log base 4. So the only thing that's left in this problem is to take this 3, and that's going to go down in the front. So I get a final answer, log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And again, notice at the beginning we said that we should have 3 separate log terms, and we in fact do. Okay, next one over here. First thing I see is I've got a big fraction, and I've got this root. So we're going to do 2 things in one. First, we're going to split this apart. So we're going to do natural log of the top, but I'm going to change that into, instead of a root, I'm going to change it into a power. So remember, a square root is the same thing as the 1/2 power. And then I'm going to subtract off the natural log of 7, because that's the denominator. The last thing that we have to do is take that power and put it down in the front. Now you might be thinking to yourself, well, don't we need to split the inside of that first? Well, looking at this 1/2 power, notice that this is in parentheses. So that means that the 1/2 power is affecting everything that's in there. So it's okay to put the 1/2 power in the front first. So we're going to do 1/2 natural log 3x minus 5 minus natural log of 7. Now, let's talk about this thing. You cannot split this apart. Notice in your log properties, in every one of the log properties, look at the inside of the log. There's no addition or subtraction going on the inside of the log. There's no addition and subtraction going on the inside of the log. There's no addition and subtraction going on the inside of the log. Notice in the term or the problem we're doing right now, there's subtraction in there. Since there's subtraction in there, that means that none of the quotient or product property things apply to this problem anymore because of that subtraction in the center. This actually has to stay the way it is. That's actually the end answer. It is fully expanded. Don't try to do too much. Don't force it to be there if it's not there, okay? All right, so the rest of this, we're going to get into some problems where we're going to condense. So we're going to take terms that are split apart and we're going to mush them back together. So let's start with a numerical example. So we're going to work this problem exactly in reverse of what we just did. So the last thing we did when we were expanding was worry about our powers. So since that's the last thing we did when we were expanding, the first thing we're going to do is worry about our powers when we condense. So anytime I see a coefficient, it's going to go back up and become a power. So what I'm going to have as the first step is log 9 plus log 2 cubed minus log 3. These two terms here are added together, which means that when I mush them back together, I'm going to multiply the insides. So that's log 9 times 2 cubed minus log 3. Now doing some evaluations, 2 cubed is 8. So this is actually log of 9 times 8 minus log 3. If we multiply those together, that's log 72 minus log 3. Now to put these together, since they're subtracted, I'm now going to divide. So that's going to be log of 72 in the numerator and 3 in the denominator. And when I divide those, 72 divided by 3, I believe, gives you 24. So this gives you log of 24, which is your letter choice D. So same steps as expanding, just in the reverse order. So next one is very, very similar. So we're going to work it backwards. First thing, take the 3, put it up. So we get natural log of 4 plus natural log of 3 cubed minus natural log of 12. My first two terms are added, so we're going to do natural log of 4 times 3 cubed minus natural log of 12. 3 cubed is 27. If I multiply 27 times 4, you're going to get 108. So this is natural log of 108 minus natural log of 12. To put these together, since it's subtraction, you have to divide the interior numbers. So natural log of 108 divided by 12. And when I divide 108 by 12, it simplifies nicely into the natural log of 9. And there would be your final answer. Next problem. Again, first thing I see here, now these have x's, so they're not going to simplify into nice numbers like these did. So first thing I'm going to do, take my coefficients, they go back up top. So I'll have a log of x to the 1/2 plus log of x plus 1 cubed. Now notice I didn't write the tens in there for each one. Remember, anytime that you had just write the word log and there's no base number there, that means log base 10. So if you like writing the 10 in there every time, you're more than welcome to, but I probably never will. I copied this problem from somewhere and they had already put the 10s in. It was more of a hassle to get rid of the 10s than to just leave them in there. But for the rest of the problem, I'm not going to write the base 10s in there because they're just understood to be there. Okay, so a couple more things. I'm going to put these together using multiplication because there's a plus sign between. So we're going to do one single log, x to the 1/2 and x plus 1 cubed. Now, if you leave the answer like this, that's fully acceptable, and I will take it. Some of you may see this and say, well, the 1/2 power is the same thing as a square root. Should I change it into a square root? If you'd like to, you're more than welcome to. So you could also write the answer as log square root x, and then x plus 1 cubed. More times than not, you're going to see these fraction exponents rewritten back in their root form. It doesn't mean that it's any more correct to do that. It's just usually how they're written. So I usually change them back into roots, but it doesn't mean that you're wrong if you don't. So just keep that in mind. Okay, 2 more condense, and then we're going to talk about this last thing. All right, so again, first thing here, that 2 is going to go back up top. So I've got natural log of x plus 2 minus natural log of x. Anytime that I have subtraction in the center, I'm going to rewrite this as 1 log using division. So here's how the correct answer is written, and then I'm going to show you some mistakes students make, and I'm going to X them out so you know don't do these things. This is how the answer should be written. If I do 1 natural log, I take the inside pieces and they are written as a fraction. X plus 2 on the top and x in the denominator. You can even put parentheses around the inside if you'd like. This one is the correct one. Here's what students like to do a lot, and if you do this on your quiz or you do this on your test, I'm going to take points off. So please make note of this. Number 1, it is not natural log of x plus 2 divided by natural log of x. This is 100% incorrect. Don't do this. I understand what you think that it means. The problem is it doesn't mean what you think it means. This means something completely different than what I wrote over here. Don't do this one. If you do this on your test, I'm going to take points off for it. Don't do it. The other one that happens with students a lot is they take the natural log of x plus 2 and then they divide the whole thing by x. This is also not correct. Okay, notice the only thing that in the correct one that's being divided by x is the x plus 2. The entire term is not being divided by x. Okay, these two things, I get what you mean, but they don't mean what you think they mean. So please do it correctly. Okay, notice the correct version, that one there, and notice the incorrect ones. Please don't do these. Okay, last ones. Now notice this 1/3 is on the outside of this big bracket. So that means that I'm going to condense first and then raise the power last. Okay, parentheses first. So putting these together, I'm going to have one term of log base 2. On the inside, x times x minus 4. The 1/3 stays out front. Now, if you want to, can you multiply and distribute here? Absolutely you can. If you leave them separated, that's fine. If you want to put them together, that's fine. Either way is totally fine with me. I'm going to put them together. So I'm going to do 1/3 log base 2 of x squared minus 4x. So the last thing I would do is take that power, and it's going to go back up top. So log base 2 of x squared minus 4x to the 1/3 power. Again, keeping in mind, if you want to leave it with the fraction exponent, you're more than welcome to. I'm actually going to change it into a root because more times than not, that's the way you'll see it written. So I'm going to go log base 2 of the cube root x squared minus 4x. And there would be your final answer. I will take either of these last two. I tend to write it like this, but it doesn't mean that you're wrong if you write it like the one directly above. Okay, last thing. Here's the deal with your calculator. Your calculator has two buttons on it. One of them is log and one of them is natural log. So here's the deal with those buttons. They already have the base numbers programmed into them, meaning that if you want to do something like this, log base 3 of 8, your calculator in most cases doesn't do that. So there's got to be a way around doing something like this if you can't punch in log base 3 of 8 in your calculator. The way around it is called change of base formula. So we actually can use this calculator to evaluate this using change of base formula. Here's how it works. You can use log or natural log. It doesn't matter which one you use. Notice log works and so does natural log. And I'm going to show you this problem both ways so that you believe me that it doesn't matter which one you use. All you do if you want to evaluate something like this is write log of the big number over log of the small number. So if I want to evaluate this, if I go to my calculator and I write the fraction log 8 over log 3, this is going to tell me what the evaluation is of log base 3 of 8. It's called change of base formula. So if I type that in, log 8 divided by log 3, it tells me my decimal is 1.8928. So when we do these problems, since these are rounded decimals, we want to leave a lot of decimal places. So do me a favor and leave 4. So we'll do 1.8928. Now, does it matter whether you use log or natural log? No. If I take this and I do ln of 8 over ln of 3, you're going to notice you're going to get the same answer. So look at the two answers. They are identically the same. So whether you remember that it's log over log, or you remember that it's natural log over natural log, it doesn't matter. They both give you the exact same answer. This is something that we're going to use a lot in a couple of lessons when we solve logarithmic and exponential equations. We're going to use this a lot. Okay? Last thing, when I say big number and small number, what do I mean? I don't mean the value of the number. I mean the script size. So notice the 8 is the larger script and the 3 is the smaller script. That's what I mean by log of the big number over log of the small number. So just so we're very clear, if I do something like log base 8 of 2, say I want to evaluate that. This is actually one we can do without a calculator, but just for this purpose. When I say log of the big number, the 2 is the big number because it's the bigger script. So I would rewrite this in change of base formula as natural log of 2 over natural log of 8. Or I'd write it as log of 2 over log of 8. So notice, the big number goes on top, the smaller script number goes on bottom. And in both of those cases, if we evaluate them, we're going to get 1/3 as the answer because that's what it should be. That's actually one that we could have evaluated without a calculator. Okay, if you have questions, write them down. Let me know in class.